Hi, my name is Ian McGregor and I produce the Professor Mac videos on YouTube. Today I want to explain how I use a program called Blender to create the animation which creates the movement of the character of Professor Mac and all the objects around him in those movies. Last time I showed how I use Blender with models to create the images which then go on to be added together in one continuous stream of images to create the animations. As part of that, I have to create movement of the objects, and it's that which tells a story and shows the way in which objects react under the influence of forces such as gravity. The sequence you've just seen is the first few seconds of the new video I'm working on, which is on Newton's law of universal gravitation, and that's part 2 to a series of videos on that particular topic. So here we have the sequence we saw at the beginning of this video loaded up into the video sequence editor in Blender. And what I want to do is step through that sequence and just point out some of the animations that I had to create when making the video sequence. So first of all, let's play the scene in its entirety. So we can see Professor Mac is on a platform which is attached to a robotic arm, and as it comes into position, the camera switches. We see Professor Mac taking the controller which controls the robotic arm and pushing it down. So if we ignore Professor Mac for a moment, we actually see that back here the Earth is moving, and you can see it much more in this shot. You can see it slowly rotating round. So there we can see Earth, and I had to create that movement of Earth by slowly rotating the model of the Earth as part of the animation sequence. We have Professor Mac here. He's animated. You can see that as he moves round into this position, you can see his arm moving. He pushes down on the controller and starts to look towards the camera. The robotic arm is also animated. It has inside it an armature, which I'll explain in a moment what that is, and that allows me to move the arm more realistically, like it would be if it was a real robotic arm. Now, there are some subtleties within the animation that perhaps aren't obvious right away. For example, as this arm comes into place, you can see that as I play it, there is a slight bump as it comes to stop. You can see that it's flexing, moving up and down. And although you might not have immediately noticed that, it's the subtlety of that kind of animation that makes the thing look real. If that was absent, then you would notice it. You wouldn't know why there was something wrong, but it's those little details that make the difference between something looking artificial and something looking realistic. Similarly with Professor Mac, if you have a look here, just watch his face. Just before he moves his arm, his face turns to look at his arm. His arm then moves. He then pushes down on the controller, and then you can see his body moving. Look at his body moving from one side to another, which you would naturally do to compensate for the movement of your weight as you were moving your arm. So those subtleties result in a more realistic movement of the characters and the objects in the scene. So what I would like to do now is switch to another view of Blender where we can look at the models, and I can show you how I create those animation sequences. Well, here we're in another view in Blender looking at the models that I used to create the animation that you've just seen. We have the Earth, which is a rather large blue ball, but has textures on it in order to make it look like Earth when we render the scene. We have the Space Shuttle, and we have Professor Mac on the end of the robotic arm. So when we try to create movement, we have to record a number of things. We have to record the position of the object at a certain point in time and how the position of the object changes over time. So there's those two elements, the position and what the position is as a function of time. So within Blender, we have the capability to record both of these things. First of all, the time is shown here in this timeline here, and it's shown in frames. Now you will remember that we have 25 images per 1 second of animation, and each image is produced at a frame in the process of making the animation. So we have 25 frames or 25 images per second of animation. At each of these frames we can record the location, the scale, the rotation of an object using these points here that are shown on the timeline. So let's have a look at how we create some animation. Let's pop into the camera, and what we're going to do is move the robotic arm as we scroll along the timeline here. Before we do that, we need to understand how we can make objects move. And let's have a look at the robotic arm. Within the robotic arm we have what we call an armature. Now an armature is just like the bones in your body. They hold the body together. And just as you move your arm, so if you are moving your arm, the bone in your arm makes sure that the whole of your arm moves as one. And that's the same in this object here. The bone that's here, which is part of the armature, makes sure that that part of the robotic arm moves as one. And we will go into the pose mode where we can start to move the robotic arm and record its position with a function as a function of time. So let's jump into the camera mode so we can see what we're doing. And here we are on the timeline. There's a default position we have of the robotic arm at that time. Let's move forward a little bit in the timeline and let's move the arm. And we do that by doing this kind of thing here, just by moving the arm. Let's move along a little bit further and let's move it into a different position. And what you can see here is that Blender is recording the position of the arm at each point in time, and it fills in a smooth transition between one position and then the other position. So let's try and finish this off. We'll go to close to the end now of the timeline there. We'll just jump out of the camera so we can see a little bit clearer what's going on. Let's take the arm down and across here like this, and therefore that's recorded. There's the arm moving up and down. So we just jump into camera mode and let's have a little look at how that looks in real time. So there we go, that's the arm. Now similarly, Professor Mac also has an armature, which will switch on. We'll jump into pose mode, and there's various bones here that allow me to control Professor Mac's pose. So let's play around with Professor Mac a little bit. Here we'll go up to this point in the timeline. Let's say his arm is flailing around due to the robotic arm going out of control. So it's up there, so let's just have a look and see what happens. His arm moves up to there, yeah, and then maybe comes down a little bit as he tries to grab hold of the controller. Not quite there yet. And then as he's getting towards the end of the sequence, let's say he gets very close to getting, just bring it in here, gets very close to getting the controller. not quite. So let's have a look at that sequence. We'll jump into the camera. Let's have a wee look, see what happens. His arm goes up, he's grabbing for that as it goes down and out of the sight of the camera. So I'll just switch some of these elements off so we can see it a little bit more clearly, and we'll just run it. There it goes, and he's trying to grab the controller to bring the robotic arm under control. So there you go. That's how we create animation sequences. It's all about position and recording that position in time. And similarly, when it came to the Earth, you saw in the sequence at the start of this video, the Earth was slowly rotating. The way I do that is I take the Earth and I rotate it and record position as a function of time, and therefore you have this slow rotation of Earth as the sequence takes place. So next time we'll look at text and how to animate text, because I use text quite a lot in the videos to explain what objects are, to explain forces and the different elements of an equation, for example, if I'm trying to explain that. So until next time, all the best.